So someone on my Discord was kind of asking me if I can help them with recursion, and that is exactly what I'm going to do in this video. I'm going to try to walk you through what exactly is recursion, why do you want to use it, when do you want to use it, etc. So I got a little index.html file with the script, and then I have my index file here that we're going to be testing some code out, right? And over here in this page, this is where we're going to be using the debugger. I could use the debugger straight into Visual Studio's code, but I figured I'd just use the Chrome debugger since probably more people are kind of familiar with that. So what exactly is recursion? First of all, you need to understand what a function is. So let's say we had a function that basically just prints an element. Okay, just prints an element, that's it. A function, you define it like this, and you can call it or invoke the function by just putting these parentheses after it, okay? So if I were to run this, and let's just say I'll print out, I don't know, I'll make an array here called like numbers. And I'll do 1, 2, 3, 4. And let's just go ahead and print out numbers of index 0. Okay, so let's go back to the code and run this real quick. And see that it prints out 1 down here at the bottom. Pretty straightforward, right? I'm just taking index 0 from numbers and printing out. So let's actually kind of take this same example, and I'm going to make it more generic. So I could pass in a number here. So this would be like the actual index. And I'm going to print out the index here. Okay, so if I added a argument or a parameter to this function, then the argument I need to pass in could be 0 through 4, or I guess 0 through 3, right? So if I do 3, it should print out 4. Go back to the code and it prints out 4. So this should be pretty obvious to you, right? We have this function that you pass it an index and it prints out the element at that index location. So when it comes to recursion, all recursion is a function that invokes itself, right? So the fact that I'm calling this function here, I can actually call it inside of this, right? If I do this, you're going to see something crazy if I actually do this. Actually, so if I just do this, it's not going to do anything because this is the function declaration. I have to still call it somewhere. So down here at the bottom, I'm going to go ahead and just call it like this. But the main takeaway is we have a function, and inside the function block, we are calling that same function again. This is recursion. That's basically all it is. Now there's a couple of other things we need to talk about to make it not crash, because if I save this and go back to my console, notice that it just prints out 4 basically until infinity or until I run out of memory on my computer. Okay, so let's kind of understand how that's working. And one thing I think would really help with understanding recursion is to draw it out. So one thing you can do is you can map kind of nodes and edges. So if you were to imagine that this is the first time I call the function, this circle here, we call the function print an element here. So I'm going to go ahead and say print an element, make that a little bit larger. We probably want to zoom in a little bit too. All right, so we have a function which is going to be designated by this circle, and we are calling a function called print an element, but we're actually passing an index of 0 when we start off. Okay. So what happens is that when this function runs, if you read through the block of code, it goes through here, it does a console log, and then it calls print an element of 3. So that's going to call print of element of 3. In fact, let me just copy this whole thing and paste it down here. Okay, so 3 is the argument. So then if I were to run through this code again, index would be set to 3. I'm going to console log 3, and then I'm going to call print an element of 3 again. So if you imagine, this thing is just going to keep on doing the exact same logic over and over again until it runs out of memory. But also I want to talk about what is this maximum call stack size exceeded. So every time you call a function, there's stuff put onto what we call stack in memory. Okay, so the arguments are put onto memory inside the stack. And as you keep calling this over and over again, we keep pushing the number 3 into the call stack. We also push some other stuff as well, but the main thing is we keep on filling up this stack memory. And this is why you're seeing this error basically throw, because after you've done this thousands of times, your stack is kind of limited. You only have so much stuff you can put in your stack and the application crashes. So whenever you see this, you know that you're doing a recursive call and you're missing something. You're missing what we call a base case. So at some point you have to basically, tell the recursive call, hey, stop doing the recursive call because I'm going to run out of memory if I keep doing that. So let's kind of refactor this function to be more of like a real life use case. Let me just call it print numbers. And this is going to take an index, and it's also going to take an array. Okay. And what we're going to do is we're going to print out array here. like so. And I'll just go ahead and start at index 0, and I will pass in 1, 2, 3, 4. Okay, so now we're actually building a real recursive function, and the idea is that this function, when you call it with an index, a starting index, and some type of collection or list, it needs to loop through every element and print it out. So you might say, oh, why don't you just use a loop or a while loop or a for loop? You can. It turns out that every recursive function could basically be written in a iterative while loop if you wanted to. But the point I'm trying to make is like, how do you actually just loop over something simple with recursion? And then we're going to kind of step on to something more complex. All right, so let's go back and try to figure out what we need to do here. Because if we just run this code again, it's going to run for infinity and crash. So let's kind of comment that out and figure out what we need to do. So every time we call this, what we actually want to do is we probably want to increment this by 1. We also have access to the array here. So these are our arguments basically. And we'll keep doing this. We'll keep basically printing out the index like so. And then at some point we have to like just stop, right? When do we actually stop? Well, it's probably when we hit the last element of this array. So this is what we're going to be calling our base statement or a base case. And we have to make sure that every recursive function we write has one of these. So I'm going to say to do write a base case, I believe it's called, or base condition. You can go Google the real term. I'm kind of just going off of memory right now. But before you actually write your recursive function, it helps to know like what is your base condition where you need to stop doing this call. In our case, I'm going to say if we're at index equal to array.length, then we just need to return, right? Don't keep printing out this element. Otherwise, what we're going to do is we need to print out the current index that we're at, which we're doing here. And then we need to do the recursive call. Remember what I said? Every recursive function makes a call to itself. So let's make sure we call itself again. I'll call it print numbers like this. And I'm going to pass an index plus 1 and then pass in the original reference to that array that we're trying to print out. All right, so now we have a recursive function. This is what we're trying to basically learn about. Let's go back and let's go to our code and run this, and notice that it prints out 1, 2, 3, 4. So congratulations, you just successfully written a recursive function that loops over a list and prints out every element of the list, right? So this is a really basic example, but let's look at a couple more because I'm sure this doesn't fully make sense. But if we follow that same paradigm where we have a base statement or base case, and then we have a recursive call, you can actually implement quite a lot of things. So let's pretend we have another function called power, which is, I believe, what he was trying to figure out in the Discord channel. So what this function is going to do is like basically I'm going to say 2 to the 5th, right? So how do you write 2 to the 5th? It's actually 2 times 2 times 2 times 2 times 2. And it turns out you can actually use like a recursive function to figure this out, because so to understand like recursion, it also helps to break down the problem into subcalls, right? Sub-recursive calls. So in this case, how do you determine what power of 2 to 5 is? Well, it's actually power 2 to the 4th times 2. Well, how do you know what power 2 to the 4th is? It's power 2 to the 3rd times 2. And you can kind of keep doing this like so. And then at some point, power 2 to the 1, you just need to return 2 here. So this is like our base case. When we've reached some type of either 0 or 1, we just return the number itself. Other than that, we have to keep calling the function. So let's see if we can figure this out. This is going to take in a number, and this is going to take in a exponent. If I remember my math lessons correctly, this is called the exponent. But basically, how do we do this stuff? Well, we need to start with a base case. So if the exponent is equal to 1, let's just return the number, like so. And then otherwise, we need to return 2 times power. This is our recursive call here. And then I'll pass in number. Oh, I'm sorry, this won't be 2. This will be number. So number times power of number exponent minus 1. So we're just decrementing the exponent every time. And at some point, this is going to hit 1, and we're going to get back this. So let's go ahead and just console log what power of 2 to 5 is. And let's go over here and notice that it prints out 32. Another good way to kind of visualize and understand recursion is just put a debugger here. I could just put a debugger here and see what happens. So inside of our debugger, let's go ahead and step through some of this stuff. and make sure we understand what's going on. It also helps to look at the call stack. There is actually something over here called the call stack, and this is exactly what that memory issue we were seeing earlier, where it said maximum call stack exceeded. Every time you dive further and further and further into this recursive call, because remember, it's going to basically end up looking like this, although this will be called power now, because we're kind of changing how it's working. And this will be like exponent. Now that I think about it, it probably would have been clearer if I just explained that other topic like this, but whatever, I think you get the point. So we're starting off with power 2 to the 5th. That's going to call power 2 to the 4th. That's going to call power 2 to the 3rd, and it's going to keep on going down until you get 1. And then it's going to return the number, which happens to be 2, back up the call stack, and it's going to resolve all these values. So let's go ahead and step through this. The first thing we pass in is number of 2 and exponent of 5. You step over. We check, is exponent equal to 1? No, then we'll skip over. And then we'll do 2 times power of number exponent minus 1. So let's click the dive into, and notice that we just pushed something onto our call stack. Okay, we can go back and actually look at, if I go ahead and look at the scope here, I might have to zoom out some. But as I kind of go down further into the, or go up higher into the call stack, I guess the stack is going to be increasing. It's going to keep on keeping track of these numbers, right? So now we're at exponent of 3, and we're exponent of 2, exponent of 1. And let's go ahead and look at this call stack real quick, because I want to make sure I kind of make this part kind of apparent to you all. Now we have all these things over here that exist in our call stack, and notice that it kind of emulates what we saw here, right? I'm just doing a different direction. But as you keep going up the stack or down the stack, and please excuse me if I say something wrong, I'm guessing you're going down the stack versus up the stack. The latest point of your stack is going to be the latest point of the recursive call, right? So you can kind of start here, we're at exponent of 1, and then as you go back down, this is like the main thing that called it. So understanding this and like how to visualize your scope as a stack is going up is really great to understanding recursion, and just like, you know, play around with this, step through it. But now we're at the very last call of our call stack, and we're saying if exponent of 1 is equal to 1, then we just return number. So now I can start stepping out of this, and notice that the call stack starts decreasing in size, and we start getting back some actual values here. So now we're saying 2 times whatever this was, which happens to be, if you look here, it says returns 4. So this is actually returning 4 because we're doing 2 to the power of 2, which is 4. If I go back up again, so this is 2 times 4. Remember, this return value of 4 is here. If I go up again, or sorry, go back down the stack, this is 2 times 8. Go back up again. 2 times 16. Go back up again. And then I think we get, I might have explained that wrong, but this is actually going to be 15 now. So if I go here, this is going to console log the 15. All right, so if you're trying to understand recursion, I definitely recommend that you get good at the debugger and get good at like understanding your call stack, because this is the most basic recursive function that you can kind of make. I'm going to show you one more, and then we might talk about why this is useful. So another one that everyone kind of talks about is Fibonacci sequence. So the Fibonacci sequence is actually a recursive function, or can be described as a recursive function, that is going to look like this. So if I do fib of 4, so the Fibonacci sequence of 4 is actually made up of the Fibonacci sequence of 3 plus the Fibonacci sequence of 2, right? And you keep on following this pattern down. So the Fibonacci of 3 is actually the Fibonacci of 2 plus 1. And then the Fibonacci of 2, technically, I think it just returns 0. So we have a base case here where like once you're at 2, you don't need to return anything else. And then for this one, we do need to actually like output some stuff. So this would be like the Fibonacci, Fibonacci of 2 plus the Fibonacci of 1. All right, so this is a recursive call. Notice that it looks like a tree. Anytime you see a tree structure, for example, if you're building out like a file folder component system, that's a recursive tree structure. The DOM is a recursive tree structure. JSON objects are typically recursive in nature because you have objects that store objects that store objects that stores arrays and stuff like that. So anytime you have something that could be kind of visualized with a tree, usually you can use a recursive function to traverse it or do things with it, and it's really elegant in my opinion. Again, you can use just a normal while loop, and you might have to use something like breadth first search or some other algorithm to traverse the tree using a while loop. But typically recursion is a much more elegant way to do it. It might not be the most performant or proficient, but it's elegant in nature, I believe. So this is our function. And if you wanted to abstract some of these numbers away, it might make a little bit more sense of how this works, because I believe we need to put like a plus here. So this is fib of 3 is fib of 2 plus fib of 1. Fib of 4 is fib of 3 plus fib of 2. All right, so that's kind of like what we need to do. We need to add the results of those back. So if we were to go to our function, let's implement the base cases first, which happen to be these. So if we're at fib of 2 or fib of 1, we just need to return 1. So let's go over to the code real quick. I'm going to make a function called fib that takes in a number, and I'm going to call fib of 4, like so. And then the base case that we need to start with is if n is equal to 2 or n is equal to 1, then let's just return 1. And now we need to go and figure out the recursive call, okay? So what we just created here is basically emulating the same tree structure, fib of 4, although you could replace the numbers with n. This could be n minus 1, and this could be n minus 2, because if this was 4, how do you get 2 from 4? Well, you have to subtract 2, right? How do you get 3 from 4? You subtract 1. Same thing over here. This ends up being n of minus 1 and n of minus 2. But again, like these will end up resolving to 1 and 2, our base statements, and they will return early, and they'll just send back 1 here. So, right, these are going to return 1. So let's go ahead and try to return that. So now we have a recursive function. We need to make a call to ourselves. So I'm going to say return fib of n minus 1, which happens to be like this call here, plus n minus 2. Okay, so plus fib of n minus 2. So what this function is going to do is it's going to do exactly what I showed you in that tree traversal. It's going to call this one, which is going to call this one, which is going to call this one. This one happens to be 2, so it's going to return 2, or it's going to return 1. This one happens to be 1, so it's going to return 1. We're going to add those together, and we're going to get 2. This one's going to be 1, I believe, or 2, so it's going to return 1. So now we have 2 plus 1, that's going to be 4. So fib of 4 equals 4. Don't know if that's correct, but we will find out. Let's go over here and let's go ahead and see what it console logs if I were to print out what fib of 4 is. 3. I think I kind of explained that wrong. So let's actually kind of dive through like what's going on here. I think it helps if we were to add numbers. So if we're using 4 here, in this example, if we're doing 4, and this is 4 minus 2 and 4 minus 1, this will end up giving us 3 like we had before, and this will give us 2 like we had before. And then over here, we'll get 3 minus 1 gives us 2, and then 3 minus 2 gives us 1. Okay, so that's like, this is kind of visualizing the call stack. And when we get the fib of 2, I believe this is just going to return 1 here. This is going to return 1 here as well. Going to add those together, and we're going to get back 2. So that's going to return 2. This one's going to return 1. And then finally, we're going to get back a 3. Okay. So if you go over to the code and refresh, notice that it prints out a 3 here. And again, like I said, like the best way to visualize some of this stuff is put a debugger. So I'll put a debugger here. I'm going to go ahead and run this code, and let's kind of step through this to understand what's going on. So in the call stack, we've only called fib once. We're going to step through it, and we're going to see is n equal to 2 or 1. It's not, so let's just step over. And now we're going to call fib of 3 and fib of 2. So if I were to dive into this, notice that it goes straight to the call of fib of 3, and then we do that same logic again. So let's go ahead and dive in again. That goes down to fib of 2. So now we're at fib of 2, and that's going to return 1. So again, the call stack, it goes from n of 4, 3, 2. Same way you can visualize that, it's basically doing this in recursion. It's taking this path. It goes all the way down that left side of the tree, and then it's going to return that 2 because we're at n is equal to 2. So if I go back up the stack, it's going to call fib of n minus 2, which n is 3. So if you go back and visualize this, now we're going to be going down this way. Maybe it'll be helpful if I make this red. Okay, so now we're going down that way. And if we kind of dive into this, it's going to check, is n equal to 1 or 2? It is. So now it's going to return 1, and it's going to go back up the stack. So let's look at the final solution. It's going to do 3. Or sorry, it's going to do 1 plus 1, because I believe these two should have been resolved by now. So we're kind of like at this point, and it's going to add those two numbers together, and we should get back 2. So if I go ahead and just click return up, notice that it did return 2 for these. And now what's going to happen is we're going to go to this way. We're going to go down to 4 minus 2, which gives us 2. So if I hover over this, we're at 4 minus 2. That's going to dive down into that recursive call. It's going to check, is 2 equal to 2? Yes. Then it's going to return 1. And now it's going to add those two numbers together. So we're at the very last call stack here. And that's going to basically be here, adding those numbers together and returning 3. And if I go ahead and just return up, we're over here, print that out, and we get 3 to our console. So that's like the visualization of how it works. It's good to understand like the order of which it kind of dived down that tree, because you can simply change, like if I were to switch these around in code, if I were to do n of n minus 2 plus n minus 1, it's actually going to traverse this tree in a different order. It's going to go down this way first, then it's going to go back up. It's going to call this one and call this one. Then it's going to go back up. It's going to call this one, go back up, hit the 2, return the 2, and now it's going to sum up the 3. So it's going to basically swap the ordering, and you'll see that as well. If like someone says you need to left print a tree or right print a tree, that's kind of like the algorithm. You just need to switch the recursive calls from either being left to right or right to left. But that's kind of like the overview of recursion and how I'd recommend trying to learn it. Like, it's really good to draw out these diagrams and help visualize how your recursive calls are kind of diving down the tree and returning and resolving things. And once you get good at it, you're kind of doing this stuff in your head and you don't have to worry about it any further. And then again, like get good at the scope and the call stack here, because again, these are like really useful to understanding like what's going on in the code and the debugger and stepping through. Now, in terms of like how useful is this, I've only used recursion maybe once or twice in my web development career. I think it's more beneficial if you actually need to dive down a DOM tree or dive down a JavaScript object and do things with it. So a lot of lower level JavaScript libraries would probably lean heavy on recursion if they needed to do recursion. But the only time I've actually like done some real legit recursion was during like programming challenges, where if you need to do like combinations or factorials, then that's when you probably need to understand how to do some type of recursive call so you can kind of like pick and choose how you're choosing things from a data set. That's a whole nother topic. Maybe I'll get into that later. I'm sorry, not factorials. I meant to say permutations, right? So permutations and combinations. Let's say you had a list of 1, 2, 3, 4, 5. How do you write a function that gives you back all the combinations of this list? Well, it turns out you can actually use recursion, and you basically have a recursive call that either takes the element or doesn't take the element, right? So if you take the element, you're going to be 1, right? And if you don't take the element, you're going to go to a recursive call like this, where you have 2. And then the next step is you can either take the 2, you don't take the 2. So I could say 2, skip 1, or I could say 1 and 2. So maybe try to challenge yourself and build that out. But same thing with permutations, like either you start with the 1 or you don't start with the 1. So it's either going to be 1, 2, 3, 4, 5. It's either going to be 2, 1, 3, 4, 5. It's going to be 2, 3, 1, 4, 5. And then like, so the point I'm making is that you can solve some complex problems using recursion. But for the most part, unless you're like doing something really specific in code, you're probably not going to ever use this in web development. But it's good to understand because I think it is an elegant way to solve some really interesting problems. Anyway, give me a thumbs up if you thought this explanation was good, or if you thought I was kind of all over the place, let me know. Again, I highly recommend that you kind of learn how to visualize recursion like this. This is probably the best way that you can kind of get it into your brain of how stuff is working. But yeah, be sure to join my Discord if you want to ask me questions directly, or just get help from other developers who are in my Discord who are willing to help you if you're stuck on React or JavaScript, etc. And like always, like, subscribe, leave a comment. Have a good day and happy coding.